What is the largest object in our galaxy? If you guessed the supermassive black hole at the center of our galaxy, you would be wrong. The black hole at the center of our galaxy is called Sagittarius A star and has an event horizon diameter of 24 million kilometers. This is massive. For context, our own sun has a diameter of 1.4 million kilometers. This would mean that our own sun could fit within the black hole 5,000 times. With that said, Sagittarius A star is not actually the largest object in our galaxy. The title actually belongs to a star named Stephenson 218, and it has a diameter of 3 billion kilometers. It is so large in fact that our own sun could fit within the volume of Stephenson 218 10 billion times. If you replaced our own sun with Sagittarius A star, its radius wouldn't even reach out as far as Mercury. But if you replaced our sun with Stephenson 218, its radius would surpass Saturn's orbit. The true difference in scale can be seen when we place Sagittarius A star right next to Stephenson 218. Although Stephenson is bigger, it has a far weaker mass, at about 50,000 times the mass of our own sun. This is in comparison to the 4.3 million solar masses of Sagittarius A star, which holds our galaxy together, proving to my ex-girlfriend that size doesn't actually matter. Imagine we had a colony on Mars. How long do you think it would take us to communicate with them? On Earth, when we send a text message to someone, that person receives that message instantly. That's because messages travel at the speed of light, and Earth is small. Earth has a circumference of 40,000 kilometers, and light travels at a speed close to 300,000 kilometers. That means light can travel around the world 7 times in its first second. That's why messaging feels so instantaneous to us here on Earth. Messaging wouldn't feel so fast for the colony on Mars though. On average, Mars is 225 million kilometers away. That would take the message 12 minutes to travel there and another 12 minutes just to receive a reply. When Mars is on its closest approach to Earth, a message takes 3 minutes. But when Mars is on the other side of the sun, that message takes 22 minutes. This means you can't FaceTime anyone on Mars, you can't have a phone call with someone, and you definitely can't play video games with them. On average, a message to Jupiter would take 40 minutes, Uranus would take 2.7 hours, and Pluto would take 5.5 hours. These times are manageable for exploring our own cosmic neighborhood, but what if we wanted to send a message to aliens that live far beyond? The closest star system to our own is Alpha Centauri. It lies 4.37 light years away. Therefore, a message to aliens residing here would take 4 years and 4 months to get there. And this is only to the closest star. If we wanted to send a message to someone on the opposite side of the galaxy, it would take 53,340 years just to get there. If we wanted to send a message to another galaxy, such as Andromeda, the closest large spiral galaxy to us, that message would take 2.5 million years. This might be the reason why we haven't heard from any aliens yet. Well, let's imagine that we receive word from a distant alien civilization today. How long would it take us to travel to them in today's spaceships? The fastest recorded spacecraft to date is the Parker Solar Probe, which has reached a top velocity of 700,000 kilometers an hour. Although this probe didn't have any room to bring any humans on board, let's presume that this speed would be achievable to send humans off at today. At this speed, we could reach Jupiter within 50 days. Pretty impressive, right? How about the closest star system, Alpha Centauri? That trip would take 6,500 years, and Alpha Centauri is unlikely to harbour any alien life. If it's aliens we want to find, we would have to go to the TRAPPIST star system. This system has 3 planets in its Goldilocks zone, the orbital region for planets to sustain life. It lies 39 light years away, meaning getting there today would take 60,000 years. Damn. Travelling our galaxy today seems impossible. How long would it take us to travel our galaxy from edge to edge? Our own galaxy, the Milky Way, is about 100,000 light years across. To travel that distance today would take 155 million years. To travel to our neighbour, the Andromeda galaxy, would take us 3.9 billion years. And if we wanted to travel to the furthest known galaxy that we know of today, a galaxy named HD1, which we can see 13.5 billion light years away, it would take us 20 trillion years. The universe is truly massive. To put those numbers into perspective, if you wanted to count to 155 million the amount of years it takes to travel the Milky Way at a rate of one number per second, it would take you 75 days. To count to 3.9 billion, the amount of years to travel to the Andromeda galaxy, it would take you 128 years. And to count to 20 trillion, the amount of years to reach the furthest known galaxy, it would take you 634,000 years. It looks like we won't be taking any vacations to any alien worlds anytime soon. Although stars are so far and wide apart from our position in space, there are areas in our galaxy where some stars choose to group together. These stellar pockets are called globular clusters and can host tens of thousands to millions of stars, all orbiting a common center. With so many stars packed so closely together, traveling from star to star wouldn't seem so inconceivable as it does here on Earth. The typical distance between stars within a globular cluster is 1 light year. The Parker Solar Probe would take 1,500 years to travel that distance today. But there have been over 150 globular clusters spotted within our galaxy, and some star clusters are denser than others. In some globular clusters, the average distance between stars can be as short as 0.15 light years, bringing the aforementioned time of travel down to 250 years. And if you go into the center of these densely packed globular clusters, stars can be as little as 0.03 light years apart. We could travel that distance in 46 years. Remember, these times are only calculated for the speed that human-made spacecraft have achieved today. There is no doubt that if a spacefaring civilization lived in one of these clusters, that they would advance their space traveling technologies more rapidly than us. The motivation to travel the stars would literally be at their doorstep. This is speculation, of course. We have found no signs of life emitting from any of these clusters, but with the millions of stars within them, surely there has to be some life, right? Well, in 1970, we sent a radio signal to the M13 globular cluster. Aliens living in this vicinity of our galaxy can expect to receive our message in 26,000 years, which means we will only have to wait 52,000 years to hear nothing back. Earlier in this video, I explained that if we left today, we could reach the Andromeda galaxy in 3.9 billion years. That was technically a lie. You see, everything in space is moving, and the Andromeda galaxy is moving towards us. It will collide with our own galaxy in 4.5 billion years. So although it is true that it would take 3.9 billion years to reach Andromeda if it was stuck in place in space, it is not true in reality. If we left today, we could actually meet Andromeda halfway within a very short time of 1.7 billion years. But as Andromeda is moving towards us, too, our galaxy is moving away from us. I also said it would take 20 trillion years to reach the furthest known galaxy from us, HD1, except HD1 isn't actually 13.5 billion light years away. Although we can see its light 13.5 billion light years away, in reality HD1 is 33 billion light years away, a 50 trillion year journey for the Parker Solar Probe. This happens because light takes time to travel, and space itself is expanding. When we point our telescopes at HD1, we are looking to its point in space 13.5 billion years ago. In the 13.5 billion years that light took to travel to us, HD1 has travelled a further 19.5 billion years away from the point at which it emitted that light. But how did it travel 19.5 billion light years in only 13.5. At a distance of 18 billion light years, space expands faster than light relative to our area in the universe. This distance is called the cosmological event horizon, and someday, far into the future, we will never be able to see light from HD1, as light that is emitted past this point will never be able to catch up and reach Earth. This also means we can only reach places today which are within a time distance of 18 billion light years. So if we left today, we wouldn't actually meet HD1 in 20 trillion years, nor would we meet it in 50 trillion. If we left today, we would never meet the galaxy HD1, not even at the speed of light. Because it is over 18 billion light years away from us, we will never ever be able to catch up. And it's not just HD1. At the speed of light, we would only have access to galaxies within the cosmological event horizon, but this only accounts for 6% of the universe. This means 94% of the universe is completely inaccessible forever. No matter how hard we try to get there, we never ever will. Why God would create a universe that is so impossibly inaccessible is anyone's guess, but it is scary knowing that we can see galaxies and stars today that we will never ever reach and be lost to time forever. How far could a human go? Imagine we sent a baby into deep space. Let's say this baby has a lifespan of 100 years. How far would this baby go? What would they get to see by their 100th birthday? Well, today, with the speed of the Parker Solar Probe, they would see nothing but our own solar system. Hey, that's not too bad. After all, the furthest humanity has ever reached was the moon. This baby would pass Pluto and reach 0.01 light years in its first year and a half of travel. At 15 years old, our astronaut would have completed its first 1% of a full light year. In the end, this baby would get 0.065 light years away from Earth by their 100th birthday, placing them at the inner edge of the Oort cloud. This distance doesn't look so far though when we compare it to the next closest star system, Alpha Centauri. Here we can see that our baby has only completed 1.5% of the journey to Alpha Centauri. Not very far at all. But what if we could go faster? What if we could start reaching the speed of light? Something strange happens as we reach the speed of light. Time starts to slow down for the passenger on board the spaceship compared to his earthbound counterpart. This is a phenomenon called time dilation, and in theory it could allow humans to travel thousands of light years in less than a year. A great way to visualize this concept is by imagining a spaceship which has a light clock on board. A light clock would work by having two mirrors face one another with a photon bouncing between them. Each time the photon hits a mirror, the clock will tick 1 second. From within the spaceship, you would see the photon travelling up and down in a vertical line. Now imagine a stationary observer looking at that same clock, but from outside the spaceship. They would see the photon travelling a diagonal path, meaning light would have a longer distance to cover. But the speed of light is constant. It can't go faster nor slower. It will always move at 299,792,458 meters a second relative to the observer. This means the person on Earth would see the spaceship's clock tick slower relative to their own light clock, but the person inside the spaceship would still see their own clock move at the constant speed of light vertically. This illustrates how two separate people can experience time differently depending on their frame of reference. A light clock on board a spaceship travelling at 87% the speed of light ticks 1 second for every 2 seconds on Earth. If two baby twins were born on Earth, but one of the twins decided to travel at 87% the speed of light away from the Earth for 10 light years, on her return with a total of 20 light years travelled, she would find that her twin sister was 20 years old, even though she had only aged 10 years. Great! This means we can preserve the human lifespan, aging at a slower rate than here on Earth. How far would our baby get if we sent them off at 99% the speed of light? At this speed, time would pass 7 times slower on the spaceship compared to Earth. That means our baby could get 700 light years away in its lifespan of 100 years. Nice. 700 years may have passed on Earth, but at least our baby has lived long enough to reach stars far, far away. What does that distance look like on a map of our galaxy? Oh, it looks pretty small. That small circle is how far our space baby could have got in its lifespan. A circle with the radius of 700 light years. This circle accounts for 0.00005% of our galaxy. But hey, we're already travelling at 99% the speed of light. We may as well go faster. Get further. At 99.9% the speed of light, our space baby would reach 2,200 light years. At 99.99%, they would get about 7,000 light years away. At 99.999% the speed of light, our space baby would be able to reach the stars at the center of our galaxy, 22,300 light years away. And at 99.9999% the speed of light, our baby would have the potential to reach the majority of stars in our galaxy, a distance radius of 70,700 light years away from Earth. But out of all those nines, the closest 9 we could get to in terms of speed today is this 9, a singular 9 at the 4th decimal place. The Parker Solar Probe travels at 0.0065% the speed of light. That's over 1,000 times slower than just 1%. Getting to 1% the speed of light is already such a future distant task for humanity to achieve from today, that getting to 99% the speed of light looks an impossible task to achieve. If we sent a space baby out at 1% the speed of light today, they wouldn't even make it past the gravitational impact of our own God-forsaken solar system. Our solar system. That's how far a human can go. Although our galaxy seems incredibly mysterious to us today, with stars so far out of reach, we may never know what is truly out there. Not so long ago, did people have the same view about our own solar system? Before advances in high-definition telescopic photography, no one could know for certain what lied amongst our surrounding planets. It may seem ridiculous to us today, but only a little over 100 years ago, it wouldn't have been so far-fetched to believe that aliens lived on other planets within our solar system. Some people even believed aliens to live on the moon. The discovery of alien man-bats was published in the New York Sun in 1835. It stated that prolific astronomer John Herschel had observed alien creatures on the moon. These creatures included unicorn bisons, tailless beavers, and human bats, just to name a few. Although these series of articles were total fabrications, John Herschel had never claimed to have spotted these aliens. It didn't stop a significant amount of the public to believe these lies as scientific fact. After all, prominent astronomers of the time, such as John Herschel's dad, William Herschel, believed the craters on the moon to be circular towns and cities. Another astronomer, Franz von Grützen, believed moon aliens to have erected star-shaped temples in honor of the stars. The first ever science fiction movie, A Trip to the Moon, released to theaters in 1902. It depicted astronomers traveling to the moon to face a dangerous first contact with an alien civilization. But with advances in telescopes and subsequent trips to the moon, it became increasingly difficult to argue in favour for aliens residing there. With that said, what were the true mysteries awaiting the Apollo astronauts on the moon? If it wasn't man-bats or alien armies, what were the true dangers that caught them off guard? Believe it or not, a danger that Apollo astronauts did not prepare for was moon dust. The moon is covered in a grey powder-like substance which looks harmless at first. After all, it's only a bit of dirt. But unfortunately for the Apollo astronauts, they would soon come to find out that this seemingly harmless soil has the potential to be quite dangerous. Lunar soil is formed from many years of micrometeorites pulverizing the lunar surface. These collisions discharge tiny sharp fragments and particles onto the surface of the moon. Because there is no atmosphere on the moon, these particles can't be eroded any further, meaning they stay extremely sharp. This created a great deal of burden for the Apollo astronauts, as it prevented equipment from working as intended. Spacesuits would lose full mobility as dust would fill within the joints of the suit. Dust would start to clog within the seals of the spacesuits, making them less pressurized. The Apollo 12 astronauts left their lunar modules twice, with the pressure in their suits decaying each time they returned. It would have been unsafe for them to go back on the lunar surface a third time, as the pressure leakage in their suits rose too high. Dust would also penetrate through fabrics. It wore through 3 layers of material on one of the astronauts' boots. Pete Conrad noted that their spacesuits were more worn out after 8 hours on the moon compared to the 100 hours spent training. Dust would cling to suits, making it impossible not to bring it back into the lunar module. Astronauts were forced to sleep in their spacesuits to prevent irritation from dust. They would even wear their helmets inside the lunar module for extended periods of time, just to avoid it from getting into their eyes and lungs. Astronaut Gene Cernan noted that dust is the single largest problem to overcome with regards to the moon.
I think dust is probably one of the greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological, physical, or mechanical problems, except dust.
Seeing as no Apollo astronaut ever stayed on the lunar surface for more than 3 days, we have no idea how dangerous the long-term effects of moon dust could really be. On June the 6th, 1971, 3 cosmonauts, Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev, became the first men to live on board an Earth-orbiting space station. They would live on the Salyut 1 space station for 3 weeks, setting a record for the longest time spent in space at the time. Cosmonaut Viktor Patsayev also became the first man to celebrate his birthday in space. Unfortunately, these men would too become the first men to die in space. On their return home to Earth, a faulty valve seal burst open within their descent module. The men were now exposed to the vacuum of space. It is likely that they died within a minute. 27 others died in space-related deaths, but were never actually in space at the time of their perishment. This makes the crew of Soyuz 11 the only people to have ever died in space. Alongside these tragedies, there have been countless close calls. One relatively recent close call may be the most peculiar near-death experience in history. During a spacewalk outside the ISS in 2013, astronaut Luca Parmitano reported water filling into the helmet of his spacesuit. A water leak is dangerous in space. Whilst in zero gravity, water will cling to any surface it can find. For Parmitano, this meant the water leaking into his helmet started to cling to his face. At moments, this prevented him from seeing, hearing, and even stopped him from breathing through his nose. The mission had to be aborted swiftly, as there was a high chance that he could have drowned within his own suit. Using his tether, Parmitano was able to pull himself back into the airlock. Once inside safely, his crewmates removed his helmet and cleared away any water which had clung to his face. It was a close call, but if for some reason Parmitano was unable to get back into his crewmates, he could have gone down in history as the first man to drown in space. When we think of finding other life forms in our universe, we usually think of distant planets too far for us to reach. But what if we didn't have to look so far? What if we could find alien life at our doorstep? It is very likely that Mars once had a network of flowing rivers, lakes and oceans on its surface over 3 billion years ago. And where there is water, there is usually life. Excavation missions to the Red Planet may be able to uncover fossils of ancient life forms that once thrived within its oceans. But the oceans on Mars are no more. The chances of finding complex organic life still alive on Mars today is pretty slim. But what about worlds in our solar system that still have oceans to this very day? For a while now, the moon Europa of Jupiter has been thought to be one of the most hospitable places for life, other than Earth, in our solar system. On the surface, Europa looks the worst place for life. An ice-cold surface with temperatures of minus 160 degrees Celsius. But sometimes, face values can be deceiving. What lies below Europa's ice crust surface is a global ocean of salty water. And plenty ocean there is. So much so that Europa is thought to have twice as much water under its surface compared to all the oceans and seas on Earth combined. Surprising when you realize Europa is even smaller than our own moon. But how is this possible? How come there are underground oceans on Europa, and why hasn't all the water just turned to ice? Well, as Europa revolves around Jupiter, the moon's interior flexes. These flexing forces generate heat through friction, allowing for liquid water to thrive below its surface. If Europa's rocky ocean floor is heated by tidal flexing, hydrothermal vents could also supply energy in the form of chemical nutrients, possibly providing the building blocks to support life. To take a glimpse of what life might look like on Europa, we only have to look at our own hydrothermal vents here on Earth. Discovered in 1977, hydrothermal vents are rich in minerals, which provide complex organisms with the vital nutrients they need to survive. Before 1977, it was thought that life could not exist independently of the sun, but now we know that a plethora of life thrives and depends on the energy created by the Earth itself. Here we can find tube worms, sea cucumbers, squid worms, crabs, octopi, and many more. There have been over 700 new species found at hydrothermal vents since 1977. If it's possible for life to survive in these extreme environments here on Earth, it shouldn't be a major surprise to find life living in the same conditions elsewhere. One thing is for sure though, if we do find that life has emerged independently of Earth on another world in our own solar system alone, holy shit, that is a lot of life. This is Earth. It's the furthest picture of home ever taken. It was taken by the Voyager 1 probe on February the 14th, 1990, at a distance of 6 billion kilometers away. That's about 0.0006 light years away. Since then, the Voyager probe has traveled a further 18 billion kilometers away, bringing it to 0.0025 light years away from our Sun. In 300 years, Voyager 1 will reach the inner edge of the Oort cloud, finishing its journey through it in 30,000 years. In 40,000 years, it will be closer to a star other than our own. Not Alpha Centauri though, as Voyager 1 is not headed in its direction, and in 40,000 years, Alpha Centauri will no longer be the closest star system to us. Voyager 1 will pass by the star Gliese 445, getting as close as 1.6 light years to it. Not very close for any aliens to retrieve it. It won't be 303,000 years until Voyager gets really close to an alien star. It will pass the star TYC 3135 52-1 at a distance of 0.1 light years. This is only relatively close, of course, as Voyager 1 would still be 40 times further away from TYC as it is away from us today. As far as we can predict, this is the closest Voyager will get to an alien star. Though, trying to predict on such large timescales is practically impossible. On the off chance that aliens do stumble upon our space probe, a golden disc was included on board. A record, including the sights and sounds of that pale blue dot, the furthest image of Earth ever taken. Carl Sagan's description of the image before you can best describe the contents of the golden record.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam.
The golden record is predicted to survive on board Voyager 1 for a very long time. In 4.5 billion years, it is likely to see our galaxy collide with Andromeda. It may be in the distant reaches of our galaxy 8 billion years from now, when planet Earth is no more. If it's lucky, Voyager 1 could last trillions of years into the future. It will probably outlast humanity. In that case, it serves as a time capsule, captivating the human experience of our epoch, encompassing the life of our planet, a fragment of our reality, a memory of our existence for when we're gone. So we can transcend our small place in this world, transcend beyond our solar system, beyond space, beyond time, beyond comprehension. A definitive artifact, proof that our minute planet was not merely a speck of rock floating in an endless cosmos, but rather that Earth was a place capable of prescribing this universe with some meaning. Thank you. This is my first long-form video on the channel. If you see any potential in my craft, please consider donating to my Patreon. It's hard to justify making these videos without a stable income. Your donation will allow me to concentrate on making these videos, uploading them more regularly and to a higher standard. The link is in the description. If you're not in the position to donate, don't worry. A like, comment, or even a share is always appreciated. Thank you again, and see you in the next one.